through this homework assignment, you are going to get an introduction to graphing quadratics. We'll be looking at what it looks like on your calculator and on the graph and from a table. So the shape made when you're graphing a quadratic, and a quadratic, to be clear, is an equation where you've got your x is squared, okay? And it's a parabola. That's how you say that word. It's a parabola, which means it's a U shape. So as you can see over here on the graph, this is my parabola. It's shaped like a U. And a parabola has something called a vertex. The vertex is either the highest, which is the maximum then, or the lowest minimum point on the graph. So think about, you've probably heard those words before, maximum and minimum. Max would be the highest, min would be the lowest. And then it has something called an axis of symmetry. And that axis of symmetry goes right down the middle of your graph. You think about if you're in art or have taken art and think about symmetry, like when you fold a piece of paper over, it's the same on either side. So you can see that this parabola is the same on either side. It's like it's a mirror image of itself with that axis of symmetry being in the middle. It's an imaginary line. You're not going to see that on your graph, but it is useful for different things in mathematics. And it's a vertical line. So the axis of symmetry actually has an equation, and the equation is going to be an x equals equation. In this case right here, because my axis of symmetry is at -2, an x value of -2, we would say that it has an equation of x equals -2, and it's an imaginary line. So you can see over here too, this is an example of a maximum vertex. That would be a max. And then you can see here it's the bottom of the U, so that's a minimum. Or min. So for these examples, you are to identify the vertex, determine if it's a maximum or a minimum, and then state the axis of symmetry. So if you look at the graph, the vertex is either the bottom or the top of the U, and that point is -2, 0. So that's my vertex. And because it's the bottom of the U, it's considered a minimum. And the axis of symmetry that cuts through this, cuts it in half, this imaginary line, and it's x equals, the equation x equals -2. And you think about, remember, bucks and hoy. Bucks is a vertical line, and so that's what our equation would be. What's cool is you can also see the symmetry from a table. If you focus in here on your y values, they seem to be symmetric about one point. And what I mean by that is, if you look at this point right here, -2, 0, if you go on either side, it's 1, and then 4, and then 9. So it's symmetric about this point right here, and that kind of tells me that that is my vertex, -2, 0. So you can see it from the graph, and you can see it from a table. So we want you to go ahead and determine the vertex. Here you're going to determine the vertex from a table, and you're going to determine the vertex from a graph, from another graph, and then from a table. And I'm going to go over, I want you to go ahead and pause this recording, okay? So pause it, and if you haven't already, I want you to try 1 through 4, okay? I'm going to go over 1 and 2 when you get back to the recording, okay? And then you're going to have done 3 and 4 on your own. So pause it, try 1 through 4, and then play it again to see the answers for 1 and 2. All right, welcome back. So let's take a look at number 1, the vertex. If you notice, I've got symmetry. Here I see my 3's repeating, I see my 0's repeating, and they're repeating around this value right here. So my vertex would be that point, 0, -1. Is it a max or a min? Well, if you look at it, it seems that my points, if I start at 0, -1, and then I go to -2, 3, and then -1, 0, and then -2, 3, and I go to 1, 0, and then 2, 3. If you can kind of envision that, that's the bottom of my U, so that's going to be a min. And my axis of symmetry cuts right through the vertex, so it's x equals whatever the x value of my vertex is, right? And my x value value of my vertex is going to be 0. So your axis of symmetry is 0. So I'm not going to go over number 4 in this recording, so if you are stuck still, I want you to go back and listen to number 1 and let that help you with number 4. Let's look at number 2. I think it's a little bit easier to see from a graph, personally. The vertex is either bottom or the top of the U, so here's the top of the U, so I can already tell that's the max point, and that happens at 1, 2. So there's my vertex, 1, 2. And my axis of symmetry cuts right through an imaginary line, x equals, cuts right through my vertex. It's always equal to that x value, my vertex, 1. Okay, so 2 can help you with number 3, and I'm not going to go over those, so you're expected to do that on your own. All right, next we're going to talk about finding solutions from a graph or a table. Remember, the other words for solutions are x-intercepts, roots, and zeros. So once you know the solutions, you also know the factors that are just the opposite. So if one of the solutions is -5, then the factor that gave me that solution would be x plus 5. Think about adding that 5 back to the other side to set it equal to 0 again. And that's your factor. So to find the solutions from a graph, we think of them as x-intercepts, solutions and x-intercepts. So look for where the parabola crosses the x-axis, and here that happens at 2 points, and that happens at x equals -3 and x equals 3. So my solutions are -3 and 3, and my factors would be the opposite. You can also tell from a table. Remember that solutions are also called zeros, meaning that y is 0 when you've got a solution. If you think about it, in order to cross the x-axis, what does y have to be? Well, y has to be 0. So if you look at your table, anywhere you've got a y value of 0, there's a solution, or an x-intercept, or a root. So here my two solutions are -1 and 1. You can see that here, so my factors would be the opposite, x plus 1 and x minus 1. Super important to be able to tell the solutions from a graph and a table. Alright, so we want you to go ahead and state the solutions and the factors here. Similar to what we did on the other side, I want you to go ahead and pause this. Try 5 through 8 on your own. If you're stuck or when you're ready to check yourself, I'm going to go over 5 and 6. So pause the recording and come back when you're ready to check, or if you're stuck. Alright, for number 5, it's asking for solutions. Remember, that's the same thing as x-intercepts. So, I just need to look where I cross my x-axis. And that happens at 1, x equals 1, and x equals 3. Another way you can write it, you saw on the other side, is 1, 3. So my factors for x equals 1, in order to get that, I would have had a factor of x minus 1. In order to get the solution of 3, I would have had a factor x minus 3. Now looking at my table here, I've only got one solution. It looks like I only see one y equals 0. Okay, so that's my one solution. And my solution is -2. So my factor would be x plus 2. But we're dealing with quadratics here, so something has to be squared. Well, if you recall, when we had perfect square trinomials, it just meant that we had the same factor but squared, or the same factor written out twice. That's why we only have one solution. So those would be your factors. Okay, I want you to go ahead and try number 7 and 8. If you haven't already. And by the way, 7, does this ever cross the x-axis? No. So that might mean that it has no solution. Just a little hint. All right, domain and range. So it's, we had some struggles with that maybe last semester, but domain and range for parabolas, well, the domain is always the same. The domain of a quadratic is always all real numbers. All real numbers. Unless the quadratic has an open or closed circle as its starting point. So what it means by that is, if it's kind of a funky looking quadratic, it kind of goes like that, or like this, okay, then it wouldn't be all real numbers. But any quadratic that continues forever like this, the domain is always going to be negative infinity to positive infinity. So this is even worth, oops, not a crayon. This is even worth memorizing. Negative infinity, positive infinity, or x is all real numbers, and you should recognize this real number symbol there. The range is not always the same, but it's always going to have one value and then an infinity. Okay, so for this one, the highest y value is 9, and the lowest, I go down forever. So remember, that's negative infinity all the way up to 9. Or you could say, in set notation, y such that y is always less than or equal to 9. Okay, so it's going to look similar, the range, but the range isn't going to be always the same because this value is going to change. Okay, so looking at example 2, again, my domain is going to be exactly the same. Negative infinity, positive infinity, or x such that x is all real numbers. Now, as far as my range goes, I see I've got a minimum. So my lowest point is negative 1. Okay, and then I go all the way up, infinity and beyond, so it goes to infinity. So how you would write that in set is y such that y is always greater than or equal to negative 1. Think about the fact that negative 1 is the lowest point, and y is always greater than that. So I want you to go ahead and try 9 and 10. I'm not going to go over those because we've been doing domain and range, so I want you to really try that and refer back to the 2 examples we just did if you're having trouble. Now, the last section is, well, what if you are not given a graph or a table, you're just given the equation? Well, then you can use your graphing calculator. So what you're going to do is hit the y equals button. That's the top left-hand button on your calculator. I know some of you it's faded. And then you're going to type in the equation. So I want you to do this. Hit y equals and type in this equation right here. X squared plus 4x plus 4. Then hit graph. And you should get a graph that looks something like this. If you did not get this graph from that equation, then go ahead and hit zoom, which is on the top row, one of the top buttons. Zoom 6, and you should see that graph. So I can tell from here that it's got a minimum, right? And the vertex is at 0. I'm sorry, not 0. The vertex is at negative 2. 0. Negative 2, 0. I can also see that it's got one solution, one x-intercept. X equals negative 2. And so that would give me a factor of x plus 2. But it needs to be squared. Something has to be squared. You can also tell from looking at the table that I've got one solution right here. I'm sorry, that is incorrect. I don't know what I'm talking about. Sometimes you see 0 and just think it's a solution. This is your solution. It has to be a y that's 0, not x. So there's your solution. You can also see that that's your vertex as well because you've got symmetry. See 1, 1, 4, 4, 9, 9, and if you were to scroll up a little bit, you'd see that symmetry continue. So we've got our solution, we've got our vertex. So what we want you to try here is to answer 11 and 12. You're going to find the vertex, whether it's a max or min, the axis of symmetry, solutions, factors, domain, range. So kind of putting it all together. Putting it all together on these last 2 problems, okay? You need to come in ready to know this stuff because when you come in the next class, we're going to be starting transformations, which means we're going to take our basic parabolas and our lines and be moving them around. So we need to be clear on all of this. If you get stuck on anything, remember you can go back in the video, rewatch parts of it, and get help that way. Okay, thanks for watching, and we will see you next class.